Today's lesson is called Energy, Spectra, and the Bohr Hydrogen Atom. It covers kind of a lot. We're going to start. Learning target 1 is to recognize that when energy exists separate from matter, it takes the form of electromagnetic radiation, of which light is an example. Let's review things we already know about energy. Energy is conserved. Energy can be stored in different ways, including the motion of particles and the arrangement of particles, and it can be transferred from one object to another, but it has to come from somewhere and it has to go somewhere. The energy of a system, this is just like matter, the energy of a system doesn't change unless energy enters or leaves the system, and when it does, the change in energy of the system is equal to the amount of energy entering or leaving. Something new about energy. The energy we've studied so far has always been stored in matter. But energy can also exist apart from matter. Energy apart from matter takes the form of an electromagnetic wave. This is an artist's representation of an electromagnetic wave. It's a pretty complicated thing. It's got oscillating, that is, waving electric field and magnetic field that are at right angles to each other. Energy that is not attached to matter moves through space as an electromagnetic wave. This energy can interact with matter when certain conditions are met. Spectroscopy is studying matter using electromagnetic radiation. We're going to look at how electromagnetic radiation is changed when it interacts with matter, and we're going to infer things about the matter. And this diagram just represents different things that can happen to radiation when it encounters matter. It can get reflected, it can pass through, it can be absorbed, or it can scatter, which means change direction. So light is an electromagnetic wave, and chemists are often a bit careless using the word light to include visible, ultraviolet, and infrared, sometimes using it to include all possible electromagnetic radiation. All of these are identical except for their wavelength and their energies, which vary with the wavelength. So the nature of electromagnetic radiation. To identify how interaction with matter changes electromagnetic radiation, we need to start by knowing more about the radiation itself. All possible electromagnetic waves make up the electromagnetic spectrum. The different kinds of waves are all the same except for their frequency, how rapidly they oscillate. To oscillate means wave back and forth, which also affects their wavelength. Radio waves are the longest and the lowest in frequency. Gamma rays are the shortest and highest in frequency. Visible light is in the middle. There's a narrow range of wavelengths that we can see called visible light. Within this band, different wavelengths appear as different colors. Red is the longest wavelength and lowest frequency of visible light. Blue-violet is the shortest wavelength and highest frequency of visible light. Now, orange, yellow, green, and blue are in between. Now, we see a mix of colors as white light. It's important to know that white light is a combination of all the different colors, that is, all the different possible wavelengths that are in the range that we're able to see. A prism or grating can separate the light by wavelength, separating the colors. So absorption spectroscopy occurs if the light interacts with matter and one color gets absorbed, that color will be missing from the spectrum when the light is separated. Then if we look at the light after it has passed through the matter, we see what's missing, and we know that the matter has absorbed that wavelength, that color of light. Emission spectroscopy. Under some circumstances, matter emits energy as light. We can put that light that's given off through a prism or grating to see just what colors are given off. This picture shows the effect of an electric current on hydrogen gas, causing it to give off light, which then we can separate the colors and look at the spectrum. In fact, that's what we're going to do later in the lesson. So let's review learning target 1. Recognize that when energy exists separate from matter, this is new, energy separate from matter, it takes the form of electromagnetic radiation, of which light is an example.